A buffer overflow is a type of vulnerability that occurs when a program writes more data to a buffer, which is a temporary storage area in computer memory than the buffer can hold. This can cause the extra data to overwrite adjacent memory locations, leading to unexpected and potentially harmful behavior. Buffer overflows are a common type of security vulnerability that can be exploited by attackers to execute malicious code, steal sensitive information, or cause a denial of service (DOS) attack. The vulnerability can be caused by various factors such as input validation errors, programming mistakes, or incorrect memory management. The consequences of a buffer overflow can range from a program crash to a serious security breach. For example, an attacker can use a buffer overflow to inject and execute malicious code on a target system, leading to data theft, system compromise, or other malicious actions. To prevent buffer overflows, software developers can use various techniques such as input validation, bounds checking, and memory-safe programming languages. Additionally, operating system vendors can implement features such as address space layout randomization, ASLR, and non-executable memory to make buffer overflow attacks more difficult. In summary, buffer overflows are a common and serious security vulnerability that can have significant consequences for computer systems and users. Developers and users should be aware of the risks and take appropriate measures to mitigate them. An integer overflow is a type of programming error that occurs when an arithmetic operation results in a value that is too large to be represented by the data type used to store it. This can cause unexpected and potentially harmful behavior, similar to buffer overflows. However, there are some key differences between integer overflows and buffer overflows. Integer overflows typically occur in numeric calculations, whereas buffer overflows occur when data is written to a buffer. Additionally, integer overflows can result in numeric errors or unexpected behavior, whereas buffer overflows can result in security vulnerabilities that can be exploited by attackers. Like buffer overflows, integer overflows can be prevented by using appropriate programming techniques such as bounds checking and input validation. Additionally, programming languages and libraries may provide features to help prevent integer overflows, such as built-in overflow detection or the ability to use larger data types for arithmetic operations. In summary, while there are some differences between integer overflows and buffer overflows, both are programming errors that can have unexpected and potentially harmful consequences. Developers should be aware of these risks and take appropriate measures to prevent them in their code.